Hello there, and welcome to this mathematics tutorial presented to you once again by O3 Schools JAMB app. Well, I have listed the virtues of the O3 Schools JAMB app so many times. Just have to remind you, the O3 Schools JAMB app is very, very efficient and quite useful for students as they learn any subject as they prepare to take their JAMB. Not just does it give you access to several past questions, it can also give you these past questions in the exam format, the mock exam format, which gives you a representation of how your JAMB app would operate. So, for those of you who are not computer savvy or who have never seen how the system would look like, those of you who are not writing the JAMB mock, which was optional, well, with your O3 Schools JAMB app, you're actually able to see how the exam looks, how the system operates, even if you do not have, or if you're not writing the mock. So just get your 3 Schools JAMB app. It is very, very useful. However, you must activate. And the activation costs 2,500 naira only. This is very, very cheap. Way, in fact, almost too cheap. A lot of us use this for lunch in one day. And even if you have to buy your actual physical past questions, you could not buy all four with 2,500 naira. But with O3 Schools JAMB app, you do not get just the four you are writing, you get access to all the subjects, every single subject. And not just the questions as your normal physical past questions will offer you, but also other features. Like you have the question search feature, in which you can search for questions using either keywords or the names of the topic. You could simply just search within that subject for a particular keyword or topic name, and the app would bring out the questions relating to that keyword you searched for. Within the mock exam, you can actually time yourself. You could increase the time, reduce the time if you also desire. You could choose one subject or all four subjects you'll be writing on that day. You could even let it set questions for you per topics you want. So within mathematics, for example, just as we are doing in this class where we are looking at quadratic equations, you could let the system actually set the exam for you on just quadratic equations. You could choose that. So because of these features, the O3 Schools JAMB app is truly one of a kind and a must get for students who want to do well in their JAMB. So simply get your O3 Schools JAMB app and activate it. The steps to activating are very, very simple. You shall simply see them in your app once you open it. And for your payment, there are different ways of paying. You could pay through Google Play. You could pay through Paystack, where you just simply pay with your ATM card and which your app is activated instantly. Or you could do a bank transfer, by with POS with your normal phone and your account. Whatever method you use, all you have to do is simply send your receipt to the number indicated on the app, and your app will get activated. All of these are 100% guarantees. There's no such story with O3 Schools JAMB app as I paid and my app was not activated. No, I assure you, pay, send your receipt, and your app will be activated instantly. So, with that, let's take a look at the topic, which is quadratic equations. Now, first off, what is a quadratic equation? How do we identify a quadratic equation in an exam? Well, quadratic equation is any equation in which the highest power of the variable is 2. Your variables are your letters. So if I was having 5x plus 3 equals to 10, this is a linear equation. The highest power of this variable here is 1. But as soon as the power becomes 2 maximum, then it becomes quadratic. 5x squared plus 3 equals to 10. This is also quadratic, though a lot of us would not realize it. I'm having x and its highest power is 2 instantly. That is a quadratic equation. It doesn't have to be in the way you know. It doesn't have to be, I think the most common format, or the way it's represented, is x squared plus, let's say, 5x plus 6 equals to 0. Something like this. Even if it is not arranged in this manner, as long as there is a letter whose highest power is 2, it must be quadratic. Which is why even that simultaneous equations at times, Some of them relate to quadratic equations. Say you are having xy equals to 8. These are two variables, and as such, they are multiplying, making their highest combined power 2. This is quadratic, meaning you shall have to solve a quadratic equation, even if there are two variables making it simultaneous. So those are what we call simultaneous equations, one linear, one quadratic. So no matter the type of equation, just know quadratic equations have a general format, and that general format is ax squared plus bx plus c equals 0, where a, b, and c are constants, while x is your variable. So that's the quadratic equation. Now, as for your solving, there are 4 ways to solve quadratic equations. 4 ways. We have the factorization method. We also have the completing the square method. Completing the square method. Then we have the quadratic formula method. The quadratic formula method. And last but not least, we have the graphical method. Well, please note that in this class, we shall not be touching 2 of these methods. The reason why is because, well, those of you who have written WAEC or who are writing WAEC this year, you would know that in your WAEC theory, you could be told, solve this question using this method. In that case, they specify to you the method they want you to use, and you must obey because they are marking your working. In JAMB, we have no such compunction. They do not compel us to follow any particular method. And as such, we are always free to choose which method we use. And well then, when choosing, we always use the 2 simplest methods, which are factorization methods and the quadratic formula method. So, because this is a video focused for JAMB students, I will not be treating, let's go to these 2. I will not be treating the completing the square method, which is actually a bit long and cumbersome, and as such, not encouraged for JAMB students at all. And as for the graphical method, while we will answer just one question on it, please note that we will not be actually using this graphical method in the way it was intended. In your work, you always have space for graph, and that graph could be a quadratic graph. That's when this method really comes into play. For our focus here, all we shall learn is what if the graph is presented in the question? How can I analyze that graph and answer? So that's all. So remember, we shall be looking at the factorization method and the quadratic formula method. It says get rid of these 2. Now, the factorization method is quite simple, but it's a little bit intricate to explain right now in words only. So we actually look at it properly when solving an example. All you need to know is that it has to do with factorizing, but we'll look at it properly when solving questions. While the quadratic formula method is commonly referred to by students as the almighty formula. Almighty formula. And the formula which you should memorize is that x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. This is the quadratic formula method. Now, please note, if for any reason, when taking your JAMB, you come across a question, quadratic equation, that you could not factorize, quickly jump to the quadratic formula method. Quadratic formula method can work for every single question. There's no question which the quadratic formula doesn't have an answer for. However, factorization method has a limitation, which is that it can only be used when factorization with whole numbers is actually possible. If I cannot factorize it, as some are, then I use my formula method. It is that simple. Okay, so please keep this formula in mind And like I said, and I'll repeat, we look at factorization method within actual solving, not just with ways. Now, we ask ourselves, are these the only things we truly have to know when looking at quadratic equations? Well, there are some simple expansions or other terms you should know. Number one expansion you should know is if you have something of this form, x plus y all squared. This is a common expansion. And you know your answer would be x squared plus 2xy plus y squared. Now, of course, you could always multiply it, but it is good you know this intricately. That way, you won't waste much time when solving. You do not have to go do the expansion and spend valuable seconds when it no. Just see anything like this, and know this is what you get. And at the same time, you see something like this, you should know this is what you get. Then, what if it was minus between these numbers? Well, not much changes. Just this point becomes minus, and every other thing remains the same. So for plus, x plus y all squared is x squared plus 2xy plus y squared. While x minus y all squared is x squared minus 2xy plus y squared. Then there's also one commonly called the difference of two squares, which is a number squared minus another number squared. And this will give you x plus y times x minus y. So always note that x squared minus y squared, as long as those numbers can be squared, will be giving you x plus y times x minus y. It comes in useful a lot of times. Now there's some other expansions which some people would like to know, but may not be very useful in this topic. But just for fun, let's also know that x plus y all cubed would be x cubed plus 3x squared y plus 3xy squared plus y cubed. This doesn't bear much use for us right now, but it's an expansion which some of us would like to remember, and for that, let's just note it. However, the ones we care about mostly are these three, as you can see, the powers are two, following them under quadratic equations. So, this is one thing you must know. Another is something known as perfect square. Perfect squares. Now, basically, if a quadratic equation is having a perfect square, that simply means that it's going to give you the same answer twice. If you want a quadratic equation that when you solve, you end up basically getting the same answer, please note that remembering the general format, very important, that as squared plus bs plus c equals to 0. Well then, most times they tell you what do you have to make your b, or what should b, or what should this be to make the quadratic equation a perfect square. Well, in that case, b squared equals to 4ac. So keep in mind, to get your quadratic equation becoming a perfect squared, b squared equals to 4ac. That's that. And then the last and very important thing we must look at in quadratic equations is, what if in this case you are given the answers to the question and you want to get the quadratic equation itself? It gets asked, what if instead of giving the quadratic equation and solving to get your answers, you're given the answers and you're being asked to go back and get your quadratic equation? Well, in that case, let's call it getting equation from roots. Please note that the answer to quadratic equations are commonly called the roots of the equation. So we want to get the equation from the roots, and the roots are, if the roots are symbolized by alpha and beta. If the roots are symbolized by alpha and beta, so get the equation from the roots. Note that the equation becomes x squared minus alpha plus beta x plus alpha beta equals 0. That's all. If I'm given the answers to the equation one more time and repeat myself. And I want to instead now get the equation from those answers. Well, x squared and it's alpha plus beta x plus alpha beta equals 0. Now, if I look at this expression here and this right here, they bear a kind of resemblance, just that this one has a behind it, while this is having 1. So to make them look identical, I will divide this one through by a. A will cancel a. I'm left with x squared. And here becomes plus b over a x plus c over a equals 0. Well, what's the point of this? These two are the same, which means that these two should be the same. There's x and x here. And as such, please note that the sum of your roots would always be equals to minus b over a, while the product of your roots would always be equals to c over a. So please note, if the question simply tells you find the sum of the roots of the equation, well, there's no need to even bother solving the equation. Just take your equation minus b. B is the constant carrying just x divided by a, where a is the constant carrying x squared. If they ask you to find the product of the roots, well, that will be c. C is a constant without any variable at all over a, constant with x squared. And these are the few key things we need to know to start actually dealing with quadratic equations. And if these are known and understood, it is then time once again for us to open our O3 Schools JAMB app and begin to solve questions. Remember, while solving these questions, we will learn how to apply both the quadratic formula and also how to use properly our factorization method of solving quadratic equations. All right, so our first question comes from the year 2017. Now, this is model 2 of the year 2017. This is question 15. And you see, this is one of the added features of your O3 Schools JAMB app. That's why it has for your CBT years, the years in which JAMB has written CBT, it has different models of questions. You have like in 2022, we have from model 1 to model 5. So there are like 5 different variations of the questions JAMB could have been asking within the year 2022. But for now, question 1 is from 2017, model 2, question 15. And this one says, if alpha and beta are the roots of 2x squared plus 5x plus 3 equals 0. Find the value of 1 over alpha plus 1 over beta. Now, this is one of those questions where some people actually end up wasting their time within JAMB. And I don't know if I should say, but JAMB loves setting these types of questions. The question is actually very easy to solve. It could take you less than, I don't know, 20 seconds. However, some of us are going to waste time by, because they told us alpha and beta are the roots of the equation, so once we now solve the equation to actually obtain those roots, and then say 1 over alpha plus 1 over beta, which whatever they get, and continue our solving. That's a long journey. How can I do this very, very simply? Just simplify this. Addition of these fractions, we know we'll find LCM of denominators. LCM will be alpha beta. Alpha beta divided by alpha is beta. And alpha beta divided by beta is alpha. Since addition is commutative, I can write this by C. What I'm actually looking for is alpha plus beta over alpha beta. Now, if you remember, in our explanations, we looked at sum of the roots of an equation and also product of the roots of an equation. That means the sum of the roots, like we noted, is minus b over a. What's my b? My b is always a number carrying just x, which is 5. So this is minus 5 over a is a number with x squared, and that is 2. While alpha beta is always going to be c over a. C is a number without any letter, which is 3, and a remains 2, which means that this expression given to me here, alpha plus beta over alpha beta, can be gotten by saying alpha plus beta is minus 5 over 2 over here means divide, and alpha beta is 3 over 2, which gives me minus 5 over 2 times this turns around 2 over 3. 2 cancels 2 minus 5 over 3, and that is all. If you check your options, that is option C. So you see, there was no reason to even bother solving the quadratic equation. Once you see a question talking about the roots of the equation, don't bother with too much wrong solving. Just get out those roots and get your answer very easily. So let's see. That was our first question. Our second question is brought to us from the year. Now we're looking at 2018 Model 2. 2018 Model 2. And this is question 38. Now for this one, the quadratic equation whose roots are 2 over 3 and minus 1 over 4 is what? We have a quadratic equation and we know the roots already. We can call this first root alpha and this one beta. Now we know the roots and they want us to generate the equation. How do we do that? We know that knowing the roots, the equation must be x squared minus alpha plus beta x plus alpha beta equals 0. So let's put these into the equation. X squared minus alpha is 2 over 3 plus minus, I will know plus times minus will be minus. So let's just do that quickly. Minus 1 over 4 plus over here I'm having alpha times beta, which is 2 over 3 times minus 1 over 4 equals to 0. And there should be x there. Okay, so let's solve these simple fractions. 4 times 3 is 12, that's my LCM. 12 over 3 is 4. 4 times 2, 8. 12 over 4 is 3 times 1, 3. X. Y over here, plus times this minus within is minus. Okay, 2 here 1. 3 into 4 is 2. So I'm left with minus 1 over 6 equals 0. So, almost done. 8 minus 3 here is 5 over 12. X minus 1 over 6 equals 0. And this should be my equation. But when I look at my options, I notice there is nothing quite like that. The options all seem to be having linear forms. They are with 12 times, which means I can turn this into all whole numbers by multiplying by the LCM of my denominators, which happens to be 12. So that 12 times x squared is 12x squared. 12 times minus 5 over 12. 12 cancels 12, leaving me with minus 5x. And 12 times 1 over 6 is going to be minus 2. And when I check my options, looking for 12x squared minus 5x minus 2, and that is option A. So you see, one more time, once you know the roots, this is your method to get the equation from the roots. Okay. Our next question. This time we are going all the way to the year 2022 to look at model 1. And this is question 11. We are told, find the values of x for 0 degrees less than x less than 90 if 2 sine squared x minus 3 sine x plus 1 equals 0. Now this may not look quadratic to you, but you simply have to check I'm having this variable that is squared and single here. What can I do? Well then, let's say let sine x equal to any letter of your choice. Let's say p. Now, I see sine x, I can replace with p. And we know that sine square x simply means sine x all squared, meaning that this sine x lives here for p squared minus 3p plus 1 equals 0. And this is a typical quadratic equation. Now, I have to solve this equation, and I'm going to show us the two different methods of solving quadratic equations within this question. Let's start with the formula method. In the formula method, remember the general form is ax squared. But instead of x, my variable here is p. So let's use ap squared plus this bp plus c equals to 0. And when I compare, a is 2, b is minus 3, and c is 1. Well then, what was the quadratic formula? The formula was that x normally, but now we're using p equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. Well, b is what? Minus 3 plus or minus the square root of, again, b squared. B is still minus 3, so that's minus 3 squared minus 4 times a, which is 2, times c, which is 1, all over 2a. And again, a is 2. You see, quite easy. Minus times minus is plus. That's going to be 3 plus or minus the square root of minus 3 squared is 9. 4 times 2 here is 8 times 1, 8. All over 2 times 2, 4. Continuing over here, I get 3 plus or minus 9 minus 8 is 1 all over 4. And as we are aware, the square root of 1 is 1. Now, once you get here, you can simply break down this plus or minus into the two separate parts, meaning p equals to 3 plus 1 over 4, or p equals to 3 minus 1 over 4, separating plus and minus. Well then, p equals to 3 plus 1 is 4, and 4 over 4 is 1, or p equals to 3 minus 1, 2 over 4. If I cancel out, 2 here is 1, 2 here is 2. So that is 1 over 2. Now, one of the typical things that happens to students here is that they begin to look at their options, as I'm about to do right now, and to ask yourself, why is there no 1 or 2 in my options? Well, the rule is your answer was not actually this. You were looking for sine x, looking for x. However, you introduced p yourself. So what we've done so far is that we've solved for p that we created by ourselves, not what they asked us for. It's now finally time for us to bring in what they actually asked us for. I would then say that p equals to, or more accurately, based on what we wrote there, sine x equals p. Now keep in mind, they told us for 0 degrees less than x less than 90, implying that we're in the first quadrant and our answer must be less than 90 but greater than 0. Therefore, let's try this one. Sine x equals to 1, and therefore x must be sine inverse of 1. Now, with the knowledge of special angles of trigonometry, you know that sine inverse of 1 is 90 degrees. Then you come this way and say sine x equal to half. And again, x equals to sine inverse of half. And one more time, sine of what angle will give you half? 30 degrees. So now I have two answers. But remember, the question says 0 less than x, also less than 90. Not less than or equal to, no, less than 90, which means 90 cannot be my answer because it must be less than 90. So the only acceptable number within the range is that x equals 30 degrees, which is option A. So I hope you understand this. This is your formula method. Now, I'm going to solve this question again using the factorization method. However, I am not going to deal with this part because this part is the same no matter what happens. Once I solve for P using my factorization method, I'm supposed to then still do this. So no matter what method I use, formula or factorization, this part is constant, and up to this part was constant, implying that all I'll be doing in this case is removing this formula method parts. So these are the parts that should go away. If I factorize, everything should still be back to the previous answer. Now let's see how that would work. Now, how does factorization work? Well, factorization, we have different steps. For your first step, multiply this, your first one, and your last, the one with p squared and one without any letter. So quite simply, 2p squared times 1 equals to 2p squared. Next up, you have to look for two numbers that when they multiply, you should be able to get 2p squared, and when they add, you should be able to get minus 3. This is typical factorization. You actually have to think. It's not like formula method where you just put the formulas and you solve your way to your answer. In factorization, there's a moment where you actually have to settle down and be creative. The number has to come from you. There is no formula or package to get it. You have to be able to reason it out. 1, 2 things to multiply to give us 2. And they should be whole numbers. As we know, only two whole numbers can multiply to give us 2. It must be 2 times 1. But then don't forget about the negative part. We want to get two numbers multiplied to give me positive 2. It can be plus 2 times plus 1, but it can also be minus 2 times minus 1. Those are my options. However, within these two numbers, I want it to be done such that when they multiply to give me 2, they should also add to give me minus 3. Well, there is no way positive 2 and positive 1 gives me minus 3. But minus 2 plus minus 1, and those times minus is minus, gives me minus 3. Which means that the two numbers I require are actually minus 2 and minus 1. Now, for JAMB students who are focused on in this video, I have a short method for you. You do not have to actually continue solving your equation once you've gotten these numbers. No need for the other method or the other continuation, which I'll show you though. But the short and easy method to get your answer is simply to come over here and simply say, divide both of these numbers by whatever was here. If it is 1p squared, which means there's no number in front, there's no need to divide. But in this case where it is 2, we're going to divide both of them by 2. So minus 2 over 2 is minus 1, while this is minus 1 over 2. And once you have this, simply change the signs. They were both negative, so flip the sign, being to get plus 1 or plus half. And these will be your answers, which if you recall before, we got p equals to 1 or p equals to 1 over 2. Now this is the short method of factorizing. Get your two numbers, first stage. Once you've gotten those two numbers are confirmed they are correct, divide them by the coefficient of x squared, or in this case p squared. Once you've done that, switch their signs, and those are your answers. But again, remember I said this is not the normal method of solving. And while, like I said, for JAMB, we do not really care about this normal method of solving because nobody is marking your work. Let's just see how it is done in case you forget this shorter method. Well, the question was 2p squared minus 3p plus 1 was 0. And we had decided that the two numbers were minus 2p and minus 1p. So the normal method, the long journey method, and we call it, is to replace minus 3p with these two. And now we're having 2p squared minus, instead of minus 3p now, I'll be having minus 2p minus 1p, which is the same thing as saying minus p, plus 1 equals 0. Once you've done this, you have to group them in groups of 2. What's common within this group? They both have 2 and they both have p. That can come out. Remove 2p from 2p times p, which is 2p squared. You have just 1p remaining. Move 2p from 2p, that's 1. Then over here, if you ever have a negative number starting it, always bring out that negative. So since there's no that number common here, I bring out minus 1. Remove minus from minus, that's plus. Move minus from plus, that becomes minus. And please note that at this stage, both your brackets must be the same. Must. If they are not, you've made a mistake already. So once they are the same, you pick one of them, p minus 1. Then you take the number out here, 2p, combine with what was out here, minus 1, and equate to 0. On getting this, you can then choose each of them individually and say either p minus 1 equals 0 or 2p minus 1 equals 0. Correct items, p equal to 1 or 2p equals to 1 over 2 over 2, p equals to 1 over 2. So you see, now I have solved this question in 3 different ways, all of which leads us to the same answer. Remember, method 1 is your quadratic formula method. Method 2 is your shortcut in factorization method. And method 3 is a normal long journey in factorization method. But no matter what I did, we always arrived at the same answer, which is option A. So keep that in mind and know that that is how we can solve quadratic equations in our JAMB. The use of a formula method is when you are not able to think of those two numbers to replace your x coefficients. Once that happens, yes, you then have to use your formula method. Okay, now we have a fourth question. This one from 2022, model 3, question 28. This one says find the value of x in the equation. The equation is 2x squared plus x minus 10 equals to 0. Okay, this is very straightforward. I'm going to solve it in the two methods, but now let's solve with factorization first, and actually just the short method, so I can see how easy that is. Well, what do? Like I said, first step is to multiply this first and last. That becomes 2 times minus 10, which is minus 20. Now here's where you have to do a bit of thinking. What two numbers can multiply to give me minus 20 and add up to give me my middle number, which is plus? Since there's no number there, that means it must be plus 1. What can multiply to give me minus 20 and add to give me 1? Well, to get 20, we can try 20 times 1, 20, but no way that is adding to give me 1. What about 10 times 2, 20, but still can't add to give me 1. Then I come to 5 and 4. Remember, I want to multiply to get a negative answer. So I can have either minus 5 times 4, or I can have 5 times minus 4. Either one gives me minus 20. But which of them will give me positive value of 1? Minus 5 plus 4 is minus 1, while 5 plus minus 1 is plus 1, indicating that my two numbers are 5 and minus 4. You see, that's how we get our numbers. We have to do that reasoning ourselves. However, on getting those numbers, like I said, the short method, very easy. Divide both of them by the coefficient of x squared. So over 2 over 2. This gives me 5 over 2. And here, minus 4 over 2 gives me minus 2. Once you've done your division, simply switch their signs. If this was positive like this is, it turns into negative. So x equals to minus 5 over 2, or This was negative, so it becomes positive. X equals to 2. And then check your options. Negative 5 over 2 and positive 2. That is option A. So you see, my actual lines of solving were just about 2 lines. And your reasoning takes 5 seconds. In less than 10 seconds, you are done with your quadratic equation. It is very, very simple. Now, just to remind us, while I have done this using my factorization method, let's look at the formula method. The formula method is x equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. Remember, a is your first number, b is the one with x, and c is the last. So, since there's no number here, remember, b must be 1, so that is minus 1 plus or minus square root of b is still 1, so 1 squared minus 4 times a, the number here, which is 2, times c, the number here, which is minus 10, all over 2a. Remembering again, a is 2. So this is going to be minus 1 plus or minus square root of 1. Minus times minus plus 4 times 2, 8. 8 times 10 is 80 all over 4. So minus 1 plus or minus square root of 1 plus 80 is 81 over 4. And the square root of 81 is 9 over 4. Once you get here, separate them. X equals to minus 1 plus 9 over 4, or minus 1 minus 9 over 4. Let's finish it up right here. Minus 1 plus 9 gives me 8 over 4. Minus 1 minus 9 gives me minus 10 over 4. So x equals to or minus 5 over 2. Same answers as before. And this is the option A. So you see, this again is how we solve quadratic equations. Well then, let's take a look at one question which is graphical. You can see it within your JAMB app on your screen. 2022 Model 3, number 36. And they ask you, what is the solution of the equation plotted in the graph? All you have to do in this step is very, very, very simple. Get the equation or the root of the equation, check where your graph cuts the horizontal axis. That is all you do. You don't solve anything. Check where it cuts the horizontal axis. And in your diagram, you'll be able to see it cuts it at minus 1 and positive 3. Meaning my answer is minus 1 and 3, which is option A. So you see, these are truly very simple. And then we'll take one last question. Just one more question. And so for this last question, we are getting it from the year 2018, Model 1, question number 35. So this one says, find the values of x for which ax squared plus 2 into x plus 1 plus 3 is a perfect squared. Sorry, there's an a here. So 2 into x plus 1, a plus 3 is a perfect squared. Now please keep in mind, in this scenario, for my perfect squared, I'm not working with x actually. My quadratic equation is taking a as the variable. That's why I'm having a squared here and a here. So for all intents and purposes, as far as this equation is concerned, this x here is pretty much a constant. If I compare this to the general format of quadratic equation, which is ax squared plus bx plus c equals 0, my a here represents the number in front of this carrying squared. That means my a here is 1. My b here represents the number in front of the variable. Instead of x, my variable is a, meaning my B will be 2 into x plus 1, and C is straightforward, C is 3. And we know that for perfect squares, B squared equals to 4AC. So B is 2 into x plus 1 squared equals to 4 times 1, which is A, times C, which is 3. Well then, let's open this smaller bracket before the bigger one. 2 times x, 2x, 2 times 1, 2. Squared equals 4 times 1, 4, times 3, 12. Okay, let's see. Squared means a number times itself. So 2x times 2x is 4x squared. 2x times 2 is 4x. 2 times 2x is also 4x. And 2 times 2 is 4 equals 12. That gives me 4x squared plus 8x plus 4. Bring 12 this way. That's minus 12 equals 0. And 4x squared plus 8x, 4 minus 12 is minus 8 equals 0. Therefore, I have to solve this quadratic equation. How do I go about it? Well, as usual, if we want to factorize, we say 4 times 8. 4 times 8 is minus 32. And I will need two numbers that will multiply to give us minus 32 and also add to give us 8. However, you realize that finding those numbers will be impossible. The reason why, to get 32, I could either have 32 times 1, obviously not 8. 16 times 2, obviously not 8. 8 times 4, also obviously not 8. So factorization cannot work in this method. So remember we said, if factorization cannot work, your quadratic formula can still work. So don't panic. Factorization doesn't work means we try quadratic. Well, my quadratic formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. So that will be b here is 8 minus 8 plus or minus square root of b squared, which is 8 squared, minus 4 times a, which is 4, times c, which is minus 8, all over 2 times a, which is 4. So that's minus 8 plus or minus the square root of 8 squared, 64, minus times minus is plus, 4 times 4 is 16, and 16 times 8, let's see, 16 times 8, sorry, 16 times 8 is 128, all over 2 times 4, 8. So 64 plus 8, right, that's 64 plus 128 is going to give me plus or minus, sorry, 128 gives me 192 all over 8. This becomes minus 8 plus or minus. What is the square root of 192? And notice that then gives you a decimal number, 13.856. And this was the reason why we're not able to get the answer previously by factorizing. Now, however, if you take a look at your options, all my options are A, 2 and 1, which cannot be possible with my decimal. B, 2 and minus 1, also not possible with my decimal. C, undefined. And D, minus 2 and 1. Now, because obviously, if I continue solving my decimal, my answer will not appear to be one of those whole numbers, and I could not factorize this. I'm going to actually take my answer as the undefined value. Now, keep in mind, if this question actually had your answers in decimal form, then please shade the decimals. But because they did not, we take the undefined as our answer. So that is option C. All right. So finally, we have come to an end of this class on quadratic equations. I do hope we've learned our two methods of solving, which are the factorization and the completing the square. Sorry, the formula method. We do not use completing the square in JAMB. It is way too long. So I hope we've learned these methods and that we'll be able to solve these questions if we see them in our exams. Well, as usual, we take some questions as assignments. And let's start with the year 2020. And this time take a look at model 2, question 13. Also, go to the year 2008. Look at, doesn't have model, just look at question 2. This one is having to do with number base. But while trying to solve the number base, you fall into a quadratic equation. Also look at 2021, model 2, question 33. And then last but not least, look at 2018, model 3, question 23. Remember to comment your answers beneath this video and we shall reach out to you to verify if you are right or wrong. If wrong, we will endeavor to offer steps to lead you towards the correct answer. So, thank you very much for watching. Remember, get your O3 Schools JAMB app and activate. And you can also subscribe to this channel to watch more videos on different topics, also in different subjects. Thank you very much for watching. My name is Athanasius.